Yo, welcome back. Welcome back to the Golang tutorial series, and today we're going to be talking about slices. Well, that's a karate chop, but you get the gist. Although slices aren't as powerful as Zoro was in that clip, they're definitely an important data structure that you need to learn if you want to learn Go. So let's go ahead and start talking about it. All right, so what is a slice? A slice is a dynamically sized flexible array. Now you'll remember from our last video when we talked about arrays that an array cannot be resized during runtime. It's fixed. So once you declare it, that's the size it's going to have. But a slice is very dynamic. It can be resized during runtime, and it just gives you more power than you have with an array. So why not use a slice? The core difference between an array and a slice is that the array is actually holding the data, whereas the slice is holding a pointer to the array that holds the data. I know it sounds a little bit confusing, but let me quickly break it down what a pointer is. Alright, so like we already know, computer memory is made up of blocks. A block consists of state and an address. So what a pointer does is that it stores that address of that block in memory. So when we're talking about slices are pointers to the array, which means they're just storing the address and memory of that array. A little bit more simple explanation. Alright, let's talk about declaring slices in Go. So there are 3 different ways that you can declare a slice in Go. The first way is very similar to how we declare an array without specifying the size. The second way is by using the built-in make keyword. And the third way is by literally slicing an array. Dang, I did a karate chop again, but you know what I mean. Alright, enough talking. Let's see some code. So let's talk about the first way that we could declare a slice in Go. So you can see here in the code, I already have an example set up with slice 1. So you can see that we declare it very similarly to how we did the array in the last video. However, we're not specifying the size right here. We're only adding in the value. So we're saying this slice won't have a specified size because that's what makes it a slice. It's going to grow dynamically. It's going to be of type int. And off the rip, we're going to have 3 values in it, 1, 2, and 3. So if you print slice 1, you'll see we'll have 1, 2, and 3 in the values. Simple, right? Before we get into these other examples, let's talk about 2 important functions that we can use for our slices. The first one is the length or len keyword, which we talked about before with arrays, and it works the same with slices. So it typically returns how many items are stored in our slice at the moment. And the next we want to talk about is capacity or cap, which basically says how big or how small our slice can shrink to before we need to reallocate more space to make room for the new items that we're trying to store in there. Alright, let's quickly look at 2 examples of us using the len and capacity keywords in Go with our slice example. So moving down to the code, you can see I already have another example made, slice 2. We declared it like we did above, but this time we're using strings just to make it a little bit different. And inside the values are Go slices are powerful. Remember that this is a slice, so we're not specifically declaring a length. So by default, the length will be however many items that we have stored in our slice at the time. So in this case, it'll be 4. So whenever we try to print out the length using the len keyword, it'll return 4 because we have 4 values in our slice. The same thing with the capacity. We never specify the capacity, which you really can't do in this type of declaration. So it'll be the same, or it'll be equal to the length of the slice here. And if we print it out, you'll see we'll get Go slices are powerful. So just a quick look into the length and cap keywords in Go and how to use them, when we're trying to retrieve the length or the capacity of our given slice. Another way that we can declare slices in Go is by using the make function. This function is built in and very simple to use. This function works by simply allocating and initializing new slice variables for us. It takes in 3 arguments or parameters, with the first argument being 1 is the type. So whether it be int, string, boolean, you name it. The second one being the length. And the third, which is optional, the capacity. Quick note about using the make function. So if you do not specify capacity, your capacity will just equal to whatever you specified as the length of your slice. Now that we have a basic overview of what the make function does and what it is, let's actually look at it in the code. So you can see here all the way up at the top of the screen, I have a new slice 4, and I'm calling the make function. So you can see, as I said earlier, this function takes 3 arguments, and the first argument being the object type, in this case int, and then next we're passing in the length. So we're saying we want a slice of length 5, and we're also passing in a capacity. So we want our capacity to be different from our length in this case. So we're specifying the capacity will be 10 instead of 5. But you can also create a slice without passing in that capacity value that we spoke of earlier. So you can see it in example 3, slice 5. So we're doing the same thing, a slice of integers, and we're giving it a length of 5. But you notice that we don't specify capacity this time. So that means our length and capacity will both equal 5, as you can see here. All right. Here we go. Back into the code. Let's talk about the final way that we can create a slice in Go. So the final method involves actually taking a slice from an existing array. So you can see here with example 4, we have array 1, which is an array of 6 integers. The way that we would create a slice from this array is by accessing this array first, so array 1, referencing that here, and putting in braces. And we're saying we want to reference starting from, or we want to create our slice starting from position 2, which would be 12 in this case, because you remember, arrays index start from 0. So 10 is at index 0, 11 is index 1, and 12 is index 2, which is where we're going to start from. And we want to go all the way to position 4 or index 4, which is 14. So if we print out this array, we would expect it to have values of 12, 13, and 14, right? Well, no, that's where we're wrong. In this case, we will only get 12 and 13 because this 4 value would only give us that 4 position, index position, minus 1, so we will only get 2. So our length of our slice in this case would be 2, and our capacity would end up being the rest of the array that we referenced, which would be 4. Had we started our slice from 0, our capacity would be 6. But in this case, since we cut out 4 spots, our capacity will be 4. So this is the final way of creating slices. If you wanted to modify a value in your slice, you would do it in the same manner as you would an array. So you simply reference the slice and you put the index that you want to change or update in brackets, and you simply insert the new value. So let's look a little bit more into that in the code. All right, this will be a quick example. So let's hurry up and get this knocked out so we can keep moving. So if you wanted to modify or access your slice element, like I said, it'll be the same way that you would when you're messing with an array. So you can see here we have slice 6, and remember, we're not specifying the length here just because it's a slice. And we're going to say it's going to have 4 values in it, 4 integer values in it. Let's say I wanted to update position 3 or index 3 to have value 20. So remember, indexes start from 0, so it'll be 0, 1, 2, 3. So the last value that we want to update would be this 4. We want to change 4 to 20. So we would say slice 6, and inside of these brackets we would put position 3. And then we print this out, we will get the actual updated value. It will no longer be 4. So the way that we modify and access slice elements are really exactly the same as you would in an array. So it's not too hard, not too hard, not too hard. Right now you're probably thinking, Cam, I'm starting to get the gist of this whole slice thing, but what if I have an existing slice and I wanted to add in some new items to the end of that slice? Is there an efficient way that I can do that? Yes. Yes. Yes.
Yes to everything you're saying. I'm so excited to get started.
There is a function called append that we can use to handle this. So what is the append function? The append function, just like the make function, is a built-in function that's meant to help working with slices a lot more easier. It takes in the slice and it takes in whatever items that you want to add in as arguments. So if I wanted to add in 2 numbers to an already existing slice, I can simply call in the append function, pass in that name of the current slice and the 2 items that I wanted to add into it, and it's that simple. All right. Almost done. Let's lock in.
Lock in for a tweak out.
So here we are back in the code, top of the screen, example 6. So let's say we have a slice 7 that we already declared, string values containing hello, I am. So you can already see the length and capacity would be 3, and the values are like we already said, hello, I am. So let's say I wanted to add in 2 more string values to this slice, just to make it a more complete thought. Hello, I am a slice. So we would simply pass in or call the built-in append function, pass in slice 7, which are the slice that we're trying to modify, and the 2 elements that we wanted to add. We can pass in more if we wanted to, but for this case, I'm only passing in 2. And if we print out this, we would get the value, hello, I am a slice, a more complete thought. Pretty dope, right? The append function also allows you to append one slice to another. So we're stacking slices out here. We ain't stacking bread, we stacking slices.
Hello, I like money.
And the way that we would do that, we would simply call in the append function as normal, pass in for our first argument the slice that we're wanting to change, and for the second argument, we would pass in the second slice followed by 3 dots or periods to let Go know to break down this slice into individual values that we can actually append on to our first slice. You'll see this somewhere floating around me as a clearer example, so I don't confuse you. Yeah. Alrighty. We are back in the code, almost done. Let's start at the top of the screen. So example 7, we're appending one slice to another. So we have slice 8 and slice 9, 2 slices that were already declared, integer type of course. So simply we will call the append function, pass in slice 8 because that's the slice that we want to add slice 9 to, and we'll pass in slice 9 followed by 3 dots or periods. These are necessary when appending elements of one slice to another. It's basically telling Go, hey, append slice 9, index 0, index 1, index 2, and so on into slice 8. That's all it does. Okay. Is it possible to copy one slice into another? You're asking the right questions because yes again to that question. It is possible to copy. Go has another built-in function. You would not believe it. They have so many built-in functions to make our lives easier. In this case, we have a built-in copy function which is used to copy slices. It works so beautifully. It takes in 2 arguments. 1 is the destination to where you want to copy, and 2 is the actual source from where you're copying it from. So your destination slice and your original slice. Really simple. All right, y'all, we almost there, bro. This is the last example. We here. We done made it. We made it to the finish line. So starting with example 8 at the top, you can see that we have our original slice, S, 3 integers, and we have an empty slice, Sn, using the make function, and we're saying the length of this slice will be equal to S, which in this case is 3. So we're calling in our copy function. Remember, it takes 2 arguments, the destination, Sn, our empty slice, and our original array S, which is our source, where we're getting our data from. After we copy this, or better yet, let me talk about why we're setting a value in right here. So the copy function also returns the number of copied elements. So in this case, it'll return 3. This isn't needed, but this is just extra data if you're writing a program that lets the user know, hey, these many values were copied here or something like that. But this is very optional. You can just call copy without using the value or the variable in. So after we copy, we expect Sn to be exactly equal to S. So to change a couple of values, we're going to say Sn index 0, we're going to set that to 0, and index 1, we're going to set that to 11. So instead of 12, 23, 34 being exactly the same across Sn, Sn, we're going to have 0, 11, and 34. So 34 would be the only value that's the same from our first copy. So that's our first example of copying from one slice to another. Moving on to our last example, let's say we have a giant array, more values than this, but for here we're going to say we're only going to have 15 integers here. And let's say we don't need all of those integers. Well, we don't need to copy all of those integers. We can specify how many we would want to copy. So let's start here. We're going to make a variable called needed numbers. And inside of this, we're going to say we only want five numbers, or we're going to declare the length of this slice to be 5. So we're taking the length of our number slice up here, and we're subtracting 10 from it. So we only want 5. We don't need all this extra data in our slice. It'll save memory and it'll make your program more efficient, using data that you actually need instead of having a whole bunch of extra data loaded. So after that, we're going to declare a copy. So we're using the making a slice, and we're going to say it's of type int. and we're going to say the length of our slice will be the needed numbers that we calculated up top, which is 5. So if we copy this using, again, destination, we wanted to copy into numbers copy, and we wanted to get that from our needed numbers slice that we made earlier. And in that case, we will only have 5 integers in our copy. It's kind of complicated the way that I explained it, but it's real simple. It's real simple. So that's it. We've made it to the finish line, y'all. I appreciate all y'all for watching this through with me. In this video, just to recap, we cover what slices are, how to declare them, the different built-in functions Go has provided us to work with slices, and we've just seen how powerful this data structure can actually be when we're coding. So as always, don't forget to like and subscribe. More content coming soon, and we made it. Appreciate y'all for tuning in. Peace out.